this man is stable enough, it will not look for hydrogen to come in to reclaim the electrons. And if this man is stable enough, it will not need any electrophile to come in to pick the electron. Whenever you are asked which is more acidic between ethanol and phenol, what is going to be your answer as a chemistry student? Now, before I explain, I would like you to comment between the two which one is more acidic. Write it at the comment section as I explain the acidity of ethanol and phenol the Chemist AI way. Stay tuned. Remember that acidity is a chemical property, and because it is a chemical property, it has to do with a functional group. Now, why do we talk about acidity between ethanol and phenol? Because they have similar functional group, OH. So there is something common about them, acidity. And what is acidity? Acidity is the ability to lose this hydrogen as a proton. When ethanol loses hydrogen as a proton, it becomes a toxide, thus plus hydrogen ion. Why is it so? Now, look at this. Oxygen is more electronegative. Therefore, the hydrogen is going to forfeit the electron pair on this bond to oxygen. Because oxygen and hydrogen have a very wide electronegativity difference, oxygen is going to attract the bond pair of electrons here towards itself, and hydrogen is going to forfeit it and come out as H+, that is hydrogen without electron. And what is remaining here is what is called a toxide, that is the ethanol, in which the oxygen group has excess electron hovering around it. That is the intermediate formed. Coming to phenol, this hydrogen will also forfeit the bonded pair of electrons to oxygen because oxygen is more electronegative. And this is what is formed. Oxygen having a negative charge, and then the hydrogen will come out as proton, H+, hydrogen without electron. Now, in both cases, we have highly unstable hydrogen ion. In both cases, these hydrogen ions are too unstable to continue to exist. So there is a tendency that they will return here to look for that electron they lost. There is a tendency that this hydrogen will return here and pick the electron so that it will re-establish the bond and form the ethanol back. The same tendency exists here, that this hydrogen will seek electron elsewhere and could not see. It will now return to pick this one, re-establish the bond, and form a more stable compound called phenol. So acidity is related to this tendency of hydrogen coming back. It is not specifically about ethanol and phenol. It is about the intermediate they form. Ethanol forms intermediate when it pushes hydrogen away as a form of acidity to become a toxide. Phenol pushes hydrogen away as a form of acidity to become an intermediate called phenoxide. Now, the acidity we are talking about is not just about the parent molecules. It is about what they form, the stability of what they form. The more stable the intermediate, the more acidic. If this man is stable enough, it will not look for hydrogen to come in to reclaim the electrons. And if this man is stable enough, it will not need any electrophile to come in to pick the electron. Now, between this man and this guy, who is more stable? Now, let us look at it from the point of view of a chemist. Now, look at this electron that is left behind. This electron is highly concentrated on one atom. It doesn't have the tendency to move elsewhere. And stability in this case is the ability of this electron that is left behind to be retained around the whole atom in this molecule. This part of the molecule is called the alkyl group. Alkyl group has what is called positive inductive effect, meaning that it pushes electron forward to an electron withdrawing group. So this alkyl group pushes electron to this oxygen plus the electron that is left behind from hydrogen. Therefore, this electron around this atom has no escape route, and because of that, it is now easier for electrophiles or species that are looking for electron to easily locate it at oxygen atom. It is just like you staying in a place that everybody knows you don't move out. To pick you is very simple. They just go there and pick you. But if you are delocalized, you are always moving around, it will be difficult to get you at a place at a particular time. Now, coming here, this electron that is left behind enters what is called resonance, because this benzene ring undergoes resonance. It has a negative inductive effect. Benzene ring here, this benzene ring, has a negative inductive effect. the pi electrons in these alternating double bonds are always moving. This pi electron at an instance will move to this place and establish a double bond. This will push this pi electron to this place to establish a double bond. This will now push this pi electron to this place to establish a new bond. And then there is a tendency for this electron around this oxygen atom to move here to establish a double bond. And once a double bond is established here, it will push this pi electron more to move to this place, and this one to move, and this one to move. And what happens? This electron around oxygen atom is now sucked inside this benzene ring and is always moving constantly. It is called resonance. Because of that, when H plus comes in to look for that electron it left behind, it will find it difficult to catch the electron at that spot where it left it. And that is why whenever phenol loses hydrogen, the hydrogen has little or no tendency to come back. And this loss of hydrogen is what is called acidity. And because of the stabilization of the phenolzide ring, the hydrogen has been lost for good. And that is why phenol is more acidic than ethanol. I hope you got value. If you did, click on like, comment, share the video, tag your friends, follow and subscribe to my YouTube channel. Bye.